In this video, I'm going to be going over dividing radicals and then introducing the concept of rationalizing, which is going to take up most of this video and a second video. So let's go straight into it and do some dividing. Before you do this, or before you watch this video, you should hopefully have already watched the video on multiplying, because that's going to inform a lot of what we do about dividing. So say I wanted to divide 10 root 30 over 2 root 6. So just like multiplying, where we multiplied the coefficients and we multiplied the radicands, here we are going to divide the coefficients and divide the radicands. So the process is pretty much the same, which is why we're not going to spend a whole lot of time on dividing, because if you know how to multiply, you pretty much already know how to divide. It will get a tiny bit more complicated just because things don't always divide neatly, but by and large, not much is going to change. So if I have 10 root 30 over 2 root 6, like we do here, I'm basically just going to divide the 10 and the 2, and I'm going to divide the root 30 and the root 6. You can think of this as basically splitting into two separate fractions, 10 over 2 and root 30 over root 6. You don't have to do this, but it's just a clean way to think about it. So 10 over 2 gets us 5. Root 30 over root 6, we just divide the radicands. 30 divided by 6 also gets me 5. So we get 5 root 5. And that's done. And that's really how dividing works. So if we had, say, 90 root 50 divided by 5 root 25, if I divided those, and I could simplify these, by the way, but I'm not going to. I'm just going to divide straight away. 90 divided by 5 gets me 18. 50 divided by 25 gets me 2. And so I've got 18 root 2. Done. Okay, but what if things don't divide neatly? So let's say we had 10 cube root 38 over 6 cube root 19. So again, I'm going to kind of split these up and think of them separately. The root 38 and the root 19, those do work cleanly, right? So 38 divided by 19 is 2, but 10 is not divisible by 6. So all we really do is we're going to simplify this like a fraction. So we've got 10 over 6. Those are both divisible by 2, so even though I can't fully divide, I can simplify, and that's just going to become 5 over 3. And so we've got 5 over 3 and cube root 2, or a slightly nicer way to write this would be 5 cube root 2 over 3. And there we go. Right, so try this next one out for yourself, see what you can make out of it, simplify it as much as you can, and we'll go from there. So I'm going to give you root 40 over 8 root 45. So pause here, simplify, get this into the cleanest version you can get, and then we'll try something else. So the 8 on the outside we can't do much with right now, but the 40 and the 45, those are both divisible by 5. So that's going to get me root 8 over 8 root 9. And so I've simplified as much as I can as far as fractions go, but we do have radicals here. And so I can simplify those roots a little bit. Root 9, that's one that we just know, that's just 3. So for now, that gets us root 8 over 8 times 3, which is just going to be root 8 over 24. But root 8 is something we can also work with. So we can do our prime factorization, we can convert that to a mixed radical. When we do, that's going to become 2 root 2. And then we still have 24 on the bottom. And so we can simplify that 2 and that 24 to get our final answer of root 2 over 12. So you really got to make sure you're simplifying stuff as much as you can. And so that's it. That's dividing. Done. There's not a whole lot to it. Really, once you've got multiplying down, dividing follows pretty cleanly. The rest of this video and the follow-up video is going to be about something a little different called rationalizing. So let's say we had something like this, 3 over root 5. I don't have anything I can simplify, right? There's only a coefficient on the top and a root on the bottom, so those don't mix. But there is something about this I don't really like. So as a general rule of thumb, It's not a hard and fast rule, but it is a sort of 95% of the time kind of rule. We don't really like having roots in our denominators. They make things more complicated. It makes it harder to add or subtract, multiply or divide, solve equations, whatever. So by and large, we don't want to have roots in denominators. At least not once we're done a question. They're fine to have sort of along the way. But once you give an answer, that's going to be something we want to avoid. So what we want to do is we want to get rid of that root 5. So to get rid of the root, we're going to have to do something a little different. And that's what rationalizing is. Quick explanation of where that comes from. You might remember from grade 9, you learned about something called rational numbers. And so a rational number is something that can be written as a fraction, an integer, a decimal that repeats, or a decimal that terminates. But what doesn't count as a rational number is something irrational, something that goes on forever and doesn't repeat itself, like pi, or roots of non-perfect numbers, like say root 2 or root 5. So let's start with about the easiest one I can give you. We want to rationalize 1 over root 2. And so the way we do that is we're going to multiply this, kind of like getting common denominators, same sort of idea. So we need to multiply the numerator and the denominator by something specific. That's going to cancel out that root. So as you're copying this down, see if you can think about it. What would you multiply the top and bottom of this fraction by in order to get rid of that root 2? The 2 is okay. It's really just the root that we need to get rid of. You can't square it, because when you square something, you change its value. So whatever we do, we can't change the overall value of this thing. So, did you come up with anything? The answer is pretty simple. If we want to cancel out a root 2, well, remember, if you multiply a root by itself, the root's going to go away. And so all we really need to multiply by here is, well, root 2. On the top, 1 times root 2 is just going to get me root 2. On the bottom, root 2 times root 2 is going to get me root 4. But we already know that root 2 times root 2 is really just going to get me 2. And so this is rationalized. I don't care about the root on the top. I'm totally fine with that. I just don't want to have that root on the bottom. And we've gotten rid of it. It's fixed. So let's try another one. If I want to rationalize, let's say 5 root 3 over root 7. So making things a little bit more complicated now. We still want to just cancel out that root 7, so I don't really care what's up top. To cancel out the root 7, we are going to multiply the top and the bottom by root 7. And then you just do whatever you do to get that. So 5 root 3 times root 7 is 5 root 21. Root 7 times root 7 is just 7. Quick little reminder for you. So remember, root a times root a, a square root times itself just gives you a, not root a. So that's going to kind of be the key principle that underpins this whole thought process. But what if there's a coefficient down there too? So let's say we had 3 root 5 over 2 root 6. So remember, our goal is just to cancel out the root. We could multiply everything by 2 root 6, and that will work, but it's going to get us bigger things than we need to. If we're just trying to cancel out the root 6, all we actually need to do is still just multiply by root 6. So when we do that, on the bottom, 2 times root 6 is just going to be 2 times 6. On the top, that's going to be 3 root 30. And so on the bottom, 2 times 6 gets me 12. And then we can simplify that 3 and that 12 to get root 30 over 4. So as sort of a general rule of thumb, so to rationalize a denominator with one term. So we will see denominators with 2 terms in the next video or the next lesson. But if there's only one term like this, you just multiply by the root on the top and the bottom. If you had multiplied it by 2 root 6 instead of just root 6, it would have worked out. It would have just been more simplifying to deal with at the end. So it is totally okay. You're not going to get the question wrong necessarily. It's just going to mean more work for you. Okay, so let's say we had a slightly more complicated numerator. So 2 root 5 minus root 3 over root 6. So we want to multiply the top and the bottom of this again by just root 6. If you do that up top, though, think really carefully. That means you're going to have to distribute. So when we do that, 2 root 5 times root 6 is going to get me 2 root 30. Root 3 times root 6 is going to get me root 18. And on the bottom, root 6 is just going to be 6. So the 2 root 30, there's not much we can do there. But this root 18, we can simplify a little bit. So this is going to get me 2 root 30 minus 3 root 2 over 6. And this is a good point for me to pause and talk about simplifying for a second. This is something that people tend to mess up a lot, and it comes up a lot in chapters 5 and 6 of this course. So looking at what we've got here, your first temptation might be to say that you can simplify something here. We've got 2, we've got 3, we've got 6. These numbers do tend to go together pretty well. But you cannot say divide both of these terms by 3, because to simplify this, you need to divide all of your terms by the same thing. So if you were to divide those two terms by 3, this 2 over here isn't divisible by 3, so it's not really going to work out. And the same thing goes for simplifying the 6 and the 2. You can't divide both of those by 2, because to do that, you'd also have to divide this 3 by 2. So when you're simplifying as a fraction, all of your terms have to be divisible by the same thing. If this had been, say, just for an example, a 12 instead of a 2, then absolutely, we could have divided all of these terms by 3. We could have simplified this a bit. But since it's just a 2, there's not much we can do here. All right, so just a couple of quick more, just to wrap things up, just to cover a couple of different sort of edge cases. So what if we've just got a couple of fractions mushed together, something like this? So 2 thirds and then 4 root 11x, like that. So what we can do is we can rewrite this. Instead of having this as 2 separate fractions, think of this as 2 and then root 4 up top, and 3 and root 11x on the bottom. This is a much easier way to work with this, and you can probably see where to go from here. So on the bottom, we're going to need to multiply by root 11x to get rid of the root. So we're going to do the same thing up top, which is going to get me 2 root 44x, and then 3 times 11x on the bottom. From that 44x, I'm going to be able to pull out a 2, which you may have noticed right from the get-go, right? We had a root 4 there, so we could have turned that into a 2 there. But either way, we're going to be able to pull out a 2 now. So this is going to become 2 times 2 and root 11x over 33x. Or as our final answer, 4 root 11x over 33x. And there's nothing else we can do there. This one's done. So the last thing we want to think about is, well, what happens if it's not a square root? What if it's a cube root? So if we've got 5 over cube root of 2 instead of 5 over just square root of 2, our first instinct is probably to say, okay, well, I'm going to multiply by cube root of 2 on the top and the bottom. So on the top, that's going to get me 5 cube root of 2 over cube root of 4. But that doesn't really help us, right? The cube root of 4 is not a nice number. So think back to prime factorization and mixed and entire radicals. If you want to pull something out of a cube root, you needed 3 of those things, right? So in order to rationalize this, in order to turn that cube root of 2 into just a 2, we need 3 2's, which means we need to multiply one more time. We're going to multiply by a cube root of 2 on the top and the bottom again, which is going to get me 5 cube root of 4 over the cube root of 8. So that cube root of 8, that is something we can work with. So we already had a 2, and we've brought in 2 more 2's to go with it. And so the cube root of 8 is just going to be 2. So this is 5 cube root of 4 over 2. And so the key thing to look out for is if your index is anything but a square root, you're just going to have to multiply more times. You need to get it to a point where you have a group of 3 of something or multiple groups of 3 of something that can all combine together and cancel out. And so that's it for this first part of rationalizing. Check in on the next video where we're going to see what happens when you have more than one term in your denominator and how that makes things much more complicated.